So in this lecture, we are going to cover what is AI, artificial intelligence. We hear it everywhere. Everyone is talking about AI in boardrooms, in meetings, in coffee shops, even in your family WhatsApp groups. But what exactly is AI? If I asked you right now, could you explain it in just one clear sentence, plain English? Chances are that you might not be able to do it. But don't worry, most people can't. They think they know, but sometimes it's very difficult to explain it. That is why in this session, we will cut through the noise and reveal what AI really means for business and leadership, how you can apply it, think clearly in plain practical terms about its use case scenario. All right. Now, AI at its core is about machines doing things we once thought only humans could do. Okay, like learning, reasoning, problem solving. Now, think of it in this way: your calculator is supposed to just crunch numbers. But Google Maps, on the other hand, thinks ahead, collects data, predicts traffic, even guides you. Now that's the shift from machines that simply do to machines that can also think, and obviously within boundaries, but they can think. Okay. Now, some of the key concepts that I want you to understand before we go deep into it, some of the jargons that you will keep hearing, you will not be able to escape them. So it's better to uh, command have a command over them. So in the next 60 seconds I will break down the key terms that is being thrown around here and there, and which you must know what it is in simple plain term. Now AI, as you all know, what is AI? Artificial intelligence. But what is it? It's machines simulating intelligence. Very simple. Okay, machines simulating, acting like intelligence. Now the second term is narrow AI. Now what we use today, Google, Maps, Alexa, Siri, okay, and many other AI tools, ChatGPT even, those are all narrow AI. Brilliant and world class, but just at one task at a time. Okay. Opposite to that, on the other end of the spectrum is general AI. Narrow AI, general AI. Okay, also called as artificial general AI. Now, this one is when machine could think uh, exponentially well, but across everything. Okay, and don't worry, this is still science fiction. We do not have that kind of capability yet. Okay, now the next is very important, which is machine learning. Okay, that's when we teach machines to learn from data instead of coding every rule. Earlier, we used to anticipate every scenario, convert it into coding rules, correct, and teach the machines or the algorithm through programming. But now, by analyzing large amounts of data as examples, our models can recognize patterns or break in it, make predictions, detect anomalies, and take decisions. So, in short, machine learning is a branch of AI where computers learn patterns from data instead of following step by step instructions. Simple, it's machine learning from experience, just like humans do. Okay. It has got various applications in our business world. Some of them you can say is email service providers. They use this kind of machine learning to spot emails, spam emails. Okay, and then they just throw it into the spam folder. You are not bothered by putting them into your inbox. That is how useful it is. Just imagine the number of productive hours you would have killed had you have to sort through all the spam emails. Another one is detecting bank frauds. You must have seen that if you are using a credit card, a particular credit card, for just say for example your grocery spending 2 3,000 5,000 at a time, and this keeps on happening. Suddenly if you buy a airline flight 50,000, okay, you will see that you received a call from the bank instantly within a matter of few seconds or a minute. How is it that happened? Because the pattern, there was a break in the pattern, and the AI detected that anomaly, and then it initiated an action. Now that again is some agentic AI concept which we will be covering later on in the lecture in this whole series. Okay, so but my point is that here also a machine learning is being used, okay, to detect fraud. Similarly, for AI enabled CCTV cameras recognizing images, machine learning is used. Okay, now there is another term which is a higher version of machine learning, which we can call as deep learning. Okay, it's nothing but machine learning on steroids. Machine learning, if you think it was so powerful, now just imagine many layers of neural networks stacked on top of one another, mimicking a brain, and therefore we term it as deep. The networks have many layers, so it's a lot of computing happening at the same time to solve a complex problem. Okay, it's a huge massive amounts of data that is being automatically worked on upon. Some of the applications of such a huge computational thing is: number one, face recognition; number two, language translation, okay, for either speech to text or text to speech; self-driving cars, things like that. Okay, so these are some of the few jargons that you must know on the tip of your tongue. And if you are not able to articulate the definition of it within, simple plain terms within one sentence, then you should just rewind to 3 minutes, see it again, see that you can just articulate that. It's very important. And to make things more easy for you to understand, picture this: you buy your kid a toy robot. Okay, at first it only follows commands: walk forward 10 steps, take a right, take a left. That's programming. But then you showed that robot 100 images of dogs, and let's say 100 images of cats. Now the next time you show him a image of a dog, it shouts dog or a cat respectively. If you showed him an image of a cat, now that's machine learning from experience. Okay, now add speech to this. Okay, instead of just knowing the faces, you add voices to it, you add speech to it. That's deep learning. So programming tells machines what to do, machine learning teaches them to learn, deep learning makes them think deeper, almost like us. I hope I have made it clear for you till here. Okay, now one of the major things that I want you not just to get acclimatized with all the terms, but also see the real world applications of these concepts, of these terminologies, of these technologies. Okay, in real world, Google Maps we have covered. That is the best example of machine learning. It processes traffic data, compares patterns, predict jams, and therefore save billions of productive hours throughout the world. Can you imagine the if you multiply these billions of hours into, let's say, um, put any monetary value to this? Can you imagine the amount of money that it just saves? Similarly, Netflix, it's you watch whatever you watch, whatever you like watching. So it studies your watching habits, and then it presents you with its options that you might like this, and most probably you like that. How is that possible? Because of machine learning. Okay, AI chatbots is another example for customer support. They are digital assistants solving millions of queries within seconds, something that is not possible by a human. So in short, AI isn't in the future. It's in your pocket right now. You are handling it, you're doing it, it's in your pocket. Okay, now I want you to not get carried away with AI. So a few reality checks. AI is not magic. It's powerful, I'll give you that, but it's maths and a lot of data and a lot of computing power, hardware horsepower, and the output looks like magic, but it is not magic. It's prediction based on simulation of intelligence by past data that has been trained, that has been given to the model to think. Okay, so every prediction, every output, every decision that the AI takes, it's basically based on the data that has been fed into it. Cool. So garbage in, if you put garbage in, what will come out? Garbage. So garbage in is equal to garbage out. Remember this formula. Or gold in is equal to gold out. All right. This is very important to understand, because because of this concept, you keep seeing that these companies like OpenAI and Google Gemini, they keep feeding newer data and most recent data to their models and keep updating their models in order to keep themselves up to date with the market. Okay, but remember, what we use today is mostly narrow AI. Okay, not robots plotting world domination. Okay, and lastly, you must know what bias is. Bias is the baseline with which the model thinks. So the data that you feed it has to be unbiased. Okay, you cannot feed it biased data, because if you feed in biased data, it will give you a biased prediction or a biased output. You're with me? So as a leader, as a manager, okay, the responsibility falls on you, that you must engage with unbiased data with your AI, so that the output, the prediction that you and your company gets is unbiased. This is very important and we cannot ignore this. All right. Now I want you to play around with a few with few of the free tools. Okay, and just spend 10-15 minutes. Don't have to invest a whole day even. Okay, you don't have to have a PhD or even a paid account to try these. Just play around these. We have ChatGPT, which is OpenAI's generation Gen AI for questions, writing help, and creating creative tasks. Then we have Claude from Google. Then we have Bing from Microsoft. Okay, these are all Gen AIs. Then we have Khanmigo, which is a personal AI tutor. Now, here's a fun challenge. Ask the same question, same prompt on two different AI tools and compare their answers. You will see that the answers are different. Care to take a guess why the answer would be different? Very simple. Because the data that was used to train those models is different. Two different companies cannot have the same amount of data, cannot have the same nature of data. The data was different, and hence the input was different and the output was different. It might be sound similar, it might be factual, but the hallucination is particular to each model. Therefore, there will be difference. So this is a fun challenge to you. Put the same question and see what it gives you. Okay. Now at the end of this lecture, I will also be giving you some assignments. Okay, and some question answers, group discussion that I want you to do with your colleagues or people at home. The idea is that once you start articulating things from your tongue, okay, in your speech, you will find the gaps in your understanding, because it is very important that you become very familiarized with all these concepts and jargons and how to put it, articulate it, and put it across to the other person for him to or her to understand. Okay, because you will not, because you will come across situations where you will need to use these terms in meetings, and you will not be able to. If you are not able to, then obviously that's not a good thing. Okay, so I will be giving you some assignments at the end of this lecture. Now let's wrap this up. AI, okay, AI is simply machines simulating intelligence. It uses data, algorithms, computing power. That's it. It's not magic. It's powerful but limited. Remember, we're still using narrow AI today, like maps, chatbots, recommendations, but not human level intelligence across everything. We are quite far from general AI as of now, AGI. Okay. Now the golden rule is garbage in, garbage is equal to garbage out. So it's very important that you as leaders take control of the quality of the data that goes inside the models, is these LLMs, as well as that those data remains unbiased. Okay, and here's the final key takeaway. AI is not about machines replacing humans. It's about machines augmenting, working together with human intelligence. The future won't be about AI replacing jobs. It will be about humans who use AI replacing those who don't. So the choice is yours. Okay, I will see you in the next lecture. Please go through this again and again if need be, and let me know if you have any questions. All right, thank you.